Tony wrote the book on WebGL, literally. WebGL up and running, and another one coming soon. He will be raffling off a couple of those books, and you can get them signed by the man himself. So, big round of applause for Tony.
Great. Thank you, Peter. Thank you, Vanessa, for organizing. Many thanks to our hosts, Google, and all the sponsors. As Peter said, I'm Tony Parisi. I run the SF WebGL meetup. A quick little bit about me. You don't have to feverishly write this down. These slides will be on SlideShare, and we'll post the link later. So I've been doing 3D visualization for the web kind of as long as that's been around. It's coming on 20 years now, I have to say. Originally working on a technology called VRML, which many of you might have heard of. Some of you might have played with in middle school. A few of you might have even built something in. And on and off for the last coming on 2 decades, I have been building experiences in 3D on the web with whatever technology was available at the time. So I got very excited in around 2009 when I heard this thing, WebGL, was coming out. And after about a year of trepidation and not wanting to get too deep into it, I sort of finally jumped into it. Year after that, I wrote a book for O'Reilly, WebGL Up and Running. I've actually written a second book, which is an intermediate level book. The first one's introductory. It's called Programming 3D Applications in HTML5 and WebGL. That's going to be out in another month or so. Right now you can get the pre-release online, Safari Online, through Amazon, etc. Enough of a plug, and I do all this stuff and I consult, and I have a little startup in the city that's building 3D technology on top of WebGL. And so with that, we live in a 3D world. People move and they think and they experience in 3 dimensions. These days, a lot of our media is 3D as well, though most of the time we experience it on a flat screen, right? But the games we play, the movies we watch, even if you remember back to, 2008 election, the broadcast media we see with Wolf Blitzer stumbling around a virtual set awkwardly, this has become a sort of staple of broadcast media now. This is all done with 3D graphics, which has been done on computers for many, many decades. Historically, it's been with high-end, dedicated hardware and very expensive proprietary software. Well, not anymore. Now, the hardware you use to render 3D runs on this phone, it runs on this desktop, it runs on this Kindle Fire HDX. It runs everywhere. 3D accelerated hardware is everywhere and powers these real-time 3D experiences we're going to talk about today. More importantly, the software to create and experience this stuff is not only accessible everywhere, it's free. It's called a web browser. See if I have audio. Do I have audio on the presentation here? There we go. Okay, so this is 100,000 stars. This was a piece that was developed by the Google Data Arts team last year. It's been around for close to a year now. But to me, it illustrates the strength of HTML5 as a platform and WebGL, which is what we're going to talk about tonight. Now, if you look at this, you'll see that I'm interacting in real time with a 3D presentation that is running in my Chrome browser. And I can click on a link, and it's going to zoom me into the sun. I don't know what this is going on with this little rectangle here. We're going to ignore it. That is craziness. What's going on there? Is that my AV? I'm going to try that again. There we go. All right, so you see this virtual fly-through of our Milky Way galaxy. So imagine trying to build this 5 years ago. You would build this title. You would distribute it on a CD-ROM or DVD, right? People would maybe go into Best Buy or order it on Amazon. And if you built this, the data for it would have to be licensed. See, I don't know what that tile is. We're going to just skip this. Data for that would have to be licensed. And if you wanted to update it, you'd have to go get another CD. We're just going to let this play. I'm sick of looking at that tile. But now it's running in a web browser, and I don't know if you noticed, but when I clicked on one of those links, I'm going to try one more time because I'm brave. There we go. That's scraped from Wikipedia. So we didn't have to go get that stuff from Britannica or anything like that. So the world is our encyclopedia. This Encyclopedia Galactica that's been built was all built on HTML5. This is now a rich media platform, and that's what we're going to talk about today. Back to our PowerPoint. And so I don't know who's seen this. So that was a nice visualization application. But what we're going to see here, I'm going to bring up Firefox for this one because it runs this screamingly fast. And hopefully it's in the browser cache, kind of big content. This is an Epic Games Unreal game that was converted from their C++ code base, including an embedded programming language interpreter. It was actually cross-compiled using a technology called mscripten, compiled to JavaScript, and running in your web browser. We are now live with a full Unreal game level in JavaScript, rendered in WebGL. Let's go full screen. I'll WASD around a little bit, using the keyboard to navigate. Use the arrow keys to kind of change my camera control. I'll just go into autopilot here so you don't see me driving and futzing around. But look at this. Benchmarking, we're getting 30 FPS, and we can get higher than that. I think that's probably because of the display sync and everything else. But, you know, fast machine, you get 60 frames a second. Running in your browser, I don't know, it's probably about 20 megs of content coming in to download that level. That was a full Epic level. I mean, we're talking AAA game stuff running in our browser now. And that is all because we have WebGL. What is WebGL? It's the 3D API standard for the web. It's OpenGL ES. Do people know what that is? That is the software API that runs on this phone. And it runs on embedded systems, small devices. That's what the ES stands for, embedded systems. You program to it using JavaScript. It's shipped pretty much everywhere. After initial reluctance by Microsoft, they've included it in Internet Explorer. It runs on the Kindle Fire HDX like a bandit. I can show you this stuff later. Beautiful device, 7 inches of pure happiness, running 60 frames a second 3D. I love this thing. And supported everywhere except mobile Safari, but there are solutions for actually building HTML5 WebGL applications. I'll talk about them shortly for iOS. But on Android, you can use a browser, or you can build a web app, Kindle web app, and on the list goes on. And in fact, it's coming soon to a Bang & Olufsen TV powered by Opera. How about that? On your TV, too. So how does it work? It's an API. It is not a tag set. It's not CSS. You don't put a little, angle bracket and say cube and see a cube on the screen. That'd be nice. Maybe that will happen someday. So it's sort of like canvas drawing. Has everyone done 2D canvas API drawing or quite familiar with it? It's like that, but different at the same time. It's a low-level thing we're going to talk about in a minute. So no DOM. You got to deal with that stuff yourself, just like with Canvas. When you want to deal with picking, you have to kind of make that stuff up as you go, or use some tools, and I'm going to show you those. And there's no file format built in. I've seen so many people ask questions online about how do I see my OBJ files or my other 3D models in WebGL. Well, it's a bit of a modeling error because WebGL itself doesn't support those. The browser doesn't know how to load a 3D file natively and just show it to you. You have to write code. But thankfully you can, and thankfully you can do it in JavaScript and it runs fast. So we're going to quickly go through the anatomy of a simple WebGL program. Breeze through it because there's a lot of details to it we don't have time for. But the basic idea is you create a canvas element on your page just like you would for 2D drawing, but then you get a 3D drawing context where you get that 2D context, you get a 3D context. You create a viewport which basically says the size of the rectangle to draw into. And then from there it gets a little weird, and we're going to go through it. All right, so this is the kind of code, if you're familiar with it, for you get a canvas element somewhere, we pass that into this function, and it calls getContext. And it says, can I have a WebGL context? Older browsers, you have to say experimental-WebGL, but generally this is supported now, WebGL. If you don't succeed at that, you probably don't have WebGL support, and you put up some kind of friendly message for your user or do something else to fall back. And then you initialize the viewport. In this case, what I'm doing is I'm going to draw to the whole window. Then you have to create buffers of data to represent your 3D objects, arrays of numbers in JavaScript that you then turn into this special new thing called a typed array, which you may have heard of at this point. This is binary data that's very compact, runs very fast. It was introduced into browsers a few years ago, largely because of WebGL. And that means your 3D data, which can be very rich, is stored very compactly, and you can operate it on it quickly. The other thing you have to do, which is a little new if you're a web programmer, is you have to create things called programmable shaders. If you know OpenGL ES already, you're familiar with this. You have to write code in another programming language called OpenGL SL, which is for shader language. And it looks like C, sort of. So if you're a C programmer, you'll be kind of familiar with it. And then there are some built-ins, if you look here. It knows about matrices and vectors and 3D thingies already, because what happens is that language gets compiled, and these compiled instructions actually get sent to the graphics card, and they're executed on every vertex that's rendered on the screen, every pixel that's rendered on the screen, and the hardware just does it super fast. This kind of technology came out of Pixar back in the day. High-end renderings now brought to every machine on the planet. That's a little weird, though, a little strange to deal with, but we're going to talk about how we can avoid that. And then we get into some real weeds here, which is you got to do a lot of low-level stuff. GL itself, the API, is kind of a state machine. So you say, okay, that buffer I created earlier, now I'm going to set it, and then I'm going to draw with it. And so we go through and we do that. We clear, this is every frame, you know, you're doing a request animation frame kind of draw loop. We clear the canvas, we set up a shader. Those buffers we created before, we set them up. We have to pass matrices in to move our objects around. All this sort of complicated stuff, right? So you may be wondering at this point, how am I going to do this? Really? Seriously? Well, if you are a game programmer and you're a graphics programmer, you're probably familiar with how to do that level of OpenGL coding. You're good to go. What you'll do is you'll build your own engine for your project. Most people, though, won't do that. And the good news is you don't have to, because WebGL is an open standard, because JavaScript is fast enough. People have written a whole bunch of libraries now that can actually talk to WebGL and make things easier for you. And we're going to see some of those libraries in action in a second from me. One of the presenters tonight, Goo, has actually got a great engine with a creation tool that comes along with it, so you not only have an engine, but you can build with it. But there's a long list, and you go online and you can get these resources from me or other people about where to start in your creation process. Unless you're a glutton for punishment or you really, really want to get to the low level, you're probably not going to do the stuff I showed you a second ago. You're going to use one of these engines and toolkits. And one of the ones I'm going to talk to you about now is called FreeDot.js. Who's heard of FreeJS? You use it every day. Good, everybody, that's great. So all that funk we saw before, the 8 pages of code, it was about 300 lines if I counted, we get it onto a page now. And we're now working with objects that if you've got any familiarity with 3D graphics, or you can kind of get up the learning curve fast, they're the kind of objects you'd think about. It's a cube. It's a camera that's got a position in space. It's a light that's going to cast onto the object. You can see some shading here, right? So that's the kind of stuff the level you're probably going to work at, and the kind of stuff you're going to be doing most days, right? 3JS is really cool too because it's got a canvas renderer, an SVG renderer, or a CSS3 renderer. It is a great engine. I personally use it for my projects, and then I built a framework on top of it to make that development even easier, because what 3JS doesn't do is a lot of high-level behavior stuff, picking, and other things. You kind of have to do some grunt work. So I've added a layer, but this one is pretty great. And some amazing things have been built with it in the past. I'll quickly show you this one right here, which is the 360 car visualizer, it's called. There we go. So this stuff's in browser cache, ought to load pretty fast. But even with a clear cache, it loads pretty quickly. And we have a beautiful interactive model with a real-time shadow. And this is great. I mean, wonderful, right? I got a 3D model here. I can spin it around. That's excellent. But what's most excellent about this is, I mean, I can really configure this thing. This is an interactive application. I'm going to switch to another model. I'm going to change colors, right? What online car configurator would be complete without being able to select your colors, right? So amazing. And there's a lot of polygon detail in this thing, right? And a lot of beautiful shadows. And the lights are baked into the scene, this stuff here. So that's part of the texture map, the bitmap on the floor. But everything else is being done in real time, including the shadows. Oh, yes. Let's go back to Canary. We're going to show one more demo of something fairly Amazing. This one was also done by the Google Arts team, data arts team. Completely different from, that was prosaic, right? We had a real world physical object we were showing. This one's about data. This is about looking at the small arms trade around the globe for the last 2 decades. Now, it's kind of a sobering thought, but it's very interesting. So I can actually slide these sliders and go to different periods of time, look at the progression of the arms trade. I can look at just imports or just exports. I can actually zoom into detail on a certain country, like the Russian Federation, and see how they've been dealing the last few decades. And this was all built on an open source Google Globe project as well. So you could go take the data from this, or the code from this presentation, put your own data in. Let's say you wanted to look at the epidemiology of, help me, what's that virus going around right now everyone's freaking out about? H1N1, thank you, right? Maybe you can see the epidemiology around the planet of that. So this is the kind of experience we're talking about WebGL being able to power. But it goes beyond just, creating the models. There's all this amazing animation stuff you can do with it too. You can do morphs and skins, real-time characters. And how do you do that? That's a good question, I asked myself. How do I make content for this? The state of the art right now is a little bit like we've moved from the stone tools age of creation to the bronze age. We're getting there. The tools are coming. You're going to see Goo Create tonight. That's a step in the right direction. What people are doing today in these projects I showed you are they're exporting a single model, an OBJ file or an STL file or one of these 3D formats that's been around for a long time, and then they're hand animating it. They're hand laying it out. They're putting the lights in. You basically like, your modeler is sitting in one room and he's like, Steve, yeah, I put the light over here, and he's talking to the programmer and he's typing the things in a text editor again. Well, that's changing. That's changing. There is a format that was pretty rich and popular for a while called Collada that took all the data, the animations, the scenes, the lights, the full hierarchy, all this stuff, and got into these big fat XML files. And we've been using that to show some really sophisticated WebGL lately, but the problem is they're big fat XML files. They don't load fast, and they're not tuned up for WebGL. So there's this other cool thing coming, which I'm involved in personally, and we're going to see a lightning talk from one of the creators of later, which is called GLTF, the GL transmission format. So imagine that same kind of rich data being able to fully get into your browser real quick because all the vertex data is in typed arrays. Only the stuff that makes sense to have in JSON or high-level data is in there. And let's see if I got a link to this puppy here. Love to show you this real quick as my last demo. Yes. So we saw on the load screen the 6 megabyte model loaded in about 0.4 seconds. Now that's what we need. If any of y'all are into the web performance stuff and you go to Steve Suter's talks, right? What do we know? We know a web page has to load in less than 2 seconds end to end, right? And I mean, that's a long time, and you need to see stuff on the screen a lot more quickly than that. Well, with these kind of formats, we can do it. And this isn't, of course, just a movie. I can switch the cameras here, right? And so this came from 3D Studio Max. It was converted to Collada, exported to Collada, and then we ran a converter on it that Fabrice is going to speak later, has written, which takes the Collada and turns it into GLTF, nice and compact. So that pipeline is starting to come. So all the professional tools, 3D Studio Max, Maya, Blender, SketchUp, they will be able to support this kind of experience. Let's see if I can just go out to the free camera for a second here. You can see our little virtual city in its full glory. So there we go. So help's coming on the pipeline. Well, we talked about this earlier. Where does it run? Well, it runs pretty much everywhere. I did mention a little bump in the road with iOS. For whatever reason, Apple has not turned on WebGL support inside mobile Safari. However, they do have it running in a limited fashion in their iAds platform. So if you make an iAd to be inserted into someone's freemium game or whatever, you've got full HTML5 that you can use to build the iAd and includes WebGL. But that's kind of limited. It'd be really nice if you could hit any website with mobile Safari and the WebGL would just work. And it's a little frustrating that it hasn't happened yet. Tim Cook, if you're listening, let's talk. I'll even come down to Cupertino. I don't mind driving down there. So hopefully that will be fixed at some point. It's not yet. But the good news is there are solutions today that will let you take your HTML5 app, because I know people here in this group especially are interested in building their stuff once in HTML5 and then getting it to run everywhere. You can take your HTML5 app and sort of a la PhoneGap, There are adapter technologies for making the whole thing run inside Android and iOS platforms that don't support WebGL yet. Android, less of an issue now because most of the Android devices actually do it. And one I'm talking about here is CocoonJS. The Cocoon folks in the room somewhere, I know they're kicking around. It's a company called Ludai. They are in San Francisco, and they make a technology that basically implements the WebGL API and a couple of other APIs that aren't built into iOS or easy to use in iOS, and they give you some tools for making that all easy. And basically, with very little change to your code, you can adapt that and bring it into iOS and make an app. They'll even make the app for you. Hey, you're not an iOS coder? They'll build it. They get a cloud service doing it for you. All you have to do is sign it with your developer ID and submit it to the store. So that's really great, and I encourage you to go look at that. So, you know, getting really close here. So my opinion, and this is why I'm so happy we're here tonight, and Peter, thank you again, and Don Olmsted, thank you for suggesting I come here and talk tonight. I think we're getting to a tipping point. A year ago, Microsoft, WebGL, I don't know, security, whatever, blah, blah, blah. Well, they changed their tune, and they're really supporting WebGL pretty well. I went into Best Buy. I went up to a laptop. I hit a URL I knew was a WebGL URL with Internet Explorer. I didn't go sneakily download Chrome like I usually do on every machine I go to at Best Buy. I just went and hit it, and it worked. I hit that 100,000 stars. I hit that car. All those things I showed you, they all just worked. So that's great. I mentioned the Kindle Fire HDX. I don't know if we're going to get this on camera, but let's see here. Come on. Yeah, here we go. So here's a little interactive piece I built for my book. I don't know if you can see it from here. Car spinning around. I took this untouched. It just worked out of the box. This thing I built in HTML5 and WebGL. And then I added touch events so I can zoom and touch on different pieces of the model. That took me half a day to add the touch support. Good to go. Running at 60 frames a second. This thing screams. Amazing. Yeah, so 7-inch, great deal. Go get one. And then we have another speaker tonight, Don Olmsted, who I just mentioned. He works at Sony. You know what he did? He built the entire PS4 interface in WebGL. So there we go. 4+ million seats in one whack, WebGL powered. God bless you. The people who track sort of browser stats, this is a good one. You know that NORAD website that tracks Santa's progress around the globe every year? So they've had a WebGL thing for the last couple of years, and we saw 146% increase in people who got into the 3D experience, which meant their browser actually supported WebGL, mostly was the issue, right? I mentioned this. Opera is now powering a Bang & Olufsen TV with their devices SDK, so we're going to have smart TVs with full HTML5 in them. And tonight's event, I think we broke all the records, right? So WebGL definitely about to tip the scales, and I'm personally delighted, and I think this is really exciting. I mean, people's enthusiasm for this has been just incredible, this event tonight. So I encourage you to stay in touch. All my particulars are here. Like I said, the slideshow is going to be up on SlideShare for you, so all the URLs will be there. And I was just talking to Vanessa, and I think what I'm going to do is ask O'Reilly to get me a promo code so anybody from this meetup tonight can get a free version of the new book as an ebook. The print one you got to pay for, and I'll sign it, I promise. So we'll make sure that we get you the new book. But if you go on Amazon, search for my name, you'll see these two titles up there. And with that, thank you again, Peter. And go forth.